Thank you.
Perfect. So, good afternoon, everyone. My name is Alejandro Gutierrez from MITA, and I'm presenting health and safety topic about the task 2.6, robotic vertical facade 3D printer. I have structured the presentation in the next 4 bullet points: system description and technical specifications, transportation requirements, handling and installation requirements, and disposal activities. First of all, I would like to show you an overview of the robotic 3D printer. We have participated 4 partners to develop this system: Cartif, BIAS, Polytechnic University of Valencia, and ITA ourselves. The system is composed of 2 subsystems. On one hand, we have the global positioner. It is a 3 Cartesian axis machine. And on the other hand, we have the robotic printer that consists on a mortar pump and a UR20 cobot with a printed tool. Okay, in this slide, I list some of the main technical specifications of both subsystems. The global positioner has a range of movements of 6 by 6 by 1 meter, height, width, and depth. The speed of displacement is about 6 meters per minute each axis, with a 50% regulation up and down. It weighs 2.5 tons. It is modular and scalable. The power supply is 10 kilowatts, and it has automatic and manual modes. The robotic printer has a UR20 cobot, as I said before, with a maximum payload of 20 kilograms, 1.75 meters working range. It weighs 64 kilograms with a power supply of 1.5 kilowatts. And the mortar pump has a maximum flow of 22 liters per minute, and the power supply is 5.5 kilowatts. Okay. On these videos, we can see on the left side the global positioner moving along its y-axis, and on the right side, we can see a printing test. Can you watch the videos moving?
Yes.
Yes, okay, great. So about the transport, the global positioner needs to be disassembled to transport it into truck mount cranes due to its dimension and weight, and some specific tools are needed to transport parts safely and secured. And the robotic printer can be transported in their own box in a truck. Okay. So regarding the handling and installation, the necessary equipment and materials are the following: 2 truck mount cranes, 6-meter high scaffold, drill, chemical wall plugs and M12 screws, torque spanner and general tools, transport tools to keep parts fixed on the truck, and vertical accuracy leveling tool. The personnel required for the installation are 2 truck crane operators, because we need to operate them at the same time to unload the parts. 1 or 2 operators who work at heights, scaffolders, and at least 1 user of the robotic 3D printer system with knowledge of the machine and user's manual. About the PPE, the personal protective equipment for the installation and the use, we need the basics: protective helmets and footwear, earplugs, gloves, personal fall arrest system, high visibility clothing, and mask for mortar pouring. Okay, in the following slides, I put some 3D representation of the installation process, because when I did this presentation, we hadn't got real pictures yet, so I hope it's clear enough to understand it. So first step would be to unload the horizontal truss with the displacement cards mounted. Okay. Next step is to lift and assemble both masts. First the right one, for example, and after that the other one. After that, we have to level the masts on the base with some threaded supports it has, and also preparing the anchor plates on the facade for the bracing. Please note that this guy here hasn't got the protective equipment, so this is just a representation, okay? Okay, so far so good. After that, it's time to fix the top bracing and the bottom bracing to the masts, okay? The step number 6 is to install the robotic printer, the cobot, and the mortar pump, and also supply them with power and water, okay? So last step will be to place construction site fences to limit access of workers during the operation of the machine. However, it has safety measures to stop it in case of an obstacle or any person moving around. As we can see on the right image, these security measures we have are 2 lasers up and down, and also 2 bidimensional scanners. Okay. To use this machine, I didn't put any slide for this reason. I mean for this purpose, but we have to install some G codes on the controller to define the robot trajectories. Okay, so that will be after all this installation process. Okay, last point I want to talk about is the disposal activities. During the installation, the waste generated includes transport boxes or protection films, which can be recycled, and also concrete dust after drilling holes on the wall, nothing relevant. And during the use in the test we will carry out, we will install a mock-up facade to the trial, and these boards can be removed after each test. We will throw them away to a construction container. Okay. Also, all the mortar that could be dropped off the canvas will be collected on a protective film, and it will also be removed to the construction container. And finally, the mortar pump has to be cleaned after each test, and the waste will be just water with mortar. Okay, so I think it was quickly, few than 10 minutes. So if you may have any question, please just ask. Thank you very much.